Hi,
Hello.
nice to meet you. Would you give us the honor of a short introduction about yourself, please?
Hi, yes, so I'm Rachel Andrew. I've been working on the web for, well, over 20 years. And so I've been working with CSS really since CSS became a thing. I'm now an invited expert to the CSS working group. I've been for the last 20 years an independent sort of contractor and freelancer, these days mainly writing. I'm actually about to start full time at Google. But I do a lot of things like write docs on MDN and so on. So if you've ever referenced things on MDN about CSS, you might have read my stuff. So anyway, I hope you enjoy this talk about CSS and kind of how CSS has changed and become more of a sort of structured language, and so some of the key things to understand about it.
Cool, thank you. So I would say we hit the play button and take a look at the presentation.
For whatever reason, it's become fashionable to announce to the world that you don't really understand CSS, as if that demonstrates your brain is perhaps far too busy with important things to bother itself with trivial things like the language that controls how everything looks on the web. And I'm tired of being a CSS apologist, because at this point, anyone who claims that CSS is some kind of wild, unstructured language with no rules probably just hasn't really learned CSS. Now, that's not to say that learning CSS is always easy. However, so often people try to learn by cobbling together task-based snippets rather than figuring out why and how things actually work. A bit of time spent understanding some core things about the language will save you a lot of time later on. And so that's what this talk is about, unpacking some common points of confusion, and rather than showing copy and paste code, explaining why these things work as they do. What I would say is listen to the bits you think you already know. CSS in particular is where folk who've been doing web stuff for years carry the practices of web browsers past with them into the work that they're doing now. Things that made sense because of a bug in some browser back in 2005, and they still show up in our code. My favourite example of this is this chunk of code. It was known as the Netscape resize fix. The name came from Dreamweaver's naming of it. It basically reloaded your browser on resize. And the reason we had to do this back in the Netscape 4 days was that if you use CSS positioning and the user resized their window, all the position elements would stack up top left and require a reload to put them back. Now, this chunk of code showed up in sites years and years after Netscape 4 had ceased to be a thing. So if you couple that fact with the fact that CSS has evolved, certain things have been clarified. So there can be a lot to learn in those things that you might think are just the basics of the language. So it's worth a periodic revisit. So in this talk, I'm going to pick up some common points of confusion and places where, understanding a bit about how CSS is made might make your life a lot easier. I want to show you how to dig into the language and understand it, so you can do that with any part of CSS when you think to yourself, why on earth is it doing that? I'm going to get two things out of the way at the start. There are some bits of CSS that have got weird names, weird casing and odd rules. Now, almost all of those come down to one fact. We can't break the web. So sometimes when you ask, why is this like that? The answer is basically history. So here is a whole list of things the CSS working group would like to change but can't unless time travel is invented. So you can always check that list and see if the CSS working group also think that the thing you believe is weird is weird. The other reason some things seem odd, especially around naming, is that naming things, as I think a lot of us know, is really, really hard. Especially in CSS, some things relate to some other construct, perhaps something in traditional graphic design, but they're not quite the same because the web is different. The web is also international, and some things that seem like a really good name to English speakers might just be odd somewhere else. So because of these things, we often end up with naming that is a bit odd, and sometimes you just have to learn what things are called. Now, the web being international is a really good place to start when we're exploring new CSS. So let's think about writing modes. When Flexbox and Grid landed in our browsers, they also quietly introduced a writing mode agnostic way of working with layout. And what I mean by that is that everything that came before related to the sort of physical dimensions of the screen. So we have top, right, bottom and left, horizontal and vertical, X and Y. And suddenly you were asked to think about start and end and the block and inline dimensions. Now, these things are all related to writing mode. And they're absolutely critical to our understanding of new layout. So even if you never format a document in a writing mode other than, horizontal top to bottom that we use for English, you still need to understand this stuff. So the block dimension, that's the direction in which blocks are displayed on a page. Now English is a language written horizontally, so blocks are displayed vertically, one below the other, going down the page. Now the inline dimension is the direction words run in a sentence. In English, that is left to right horizontally. These things relate to our understanding of block and inline layout. Inline boxes display next to each other in a line. Block elements take up all the space in the inline dimension and display one after the other. If we use a vertical writing mode, now the block dimension is running horizontally and the inline vertically. If you need to think about start in the block dimension or line 1 in grid, then this is the line at which blocks would start. In English, that's at the top of the element, in a vertical RL language on the right. This is block start, where the block's end is block end. If you need to think about start in the inline direction or line 1 in grid, then this is where a sentence begins in that writing mode and direction. That's on the left for English, on the right for Arabic, at the top for a vertical writing mode. That's inline start, the other end of the line is inline end. And so here we find a tension between the fact that our new layout methods only refer to block and inline start and end, and everything else is tied to top, right, bottom and left. You can see this if you try and build something using vertical writing mode, you'll soon discover. So we've got a grid layout here, and I'm going to turn it onto its side with writing mode vertical RL. Now the grid works fine, so grid layout works exactly the same in any writing mode. But my width and height, and if I had any padding and margin, that all relates to the physical dimensions of the screen, not the logical dimensions of block or inline. So they're not related to the flow of content. And to solve this tension, we have a whole new CSS specification. It's called Logical Properties and Values. Now all it is a series of mappings. It maps flow relative logical properties to the existing physically mapped properties. So if we take our grid example, what we do then is we change the width and the height to these flow relative properties, inline size and block size. The gridded component will now work in exactly the same way, no matter which direction the writing mode is running. Because we already understand the block and inline dimensions, these names make sense. The block size property defines the size in the block dimension, the inline size, the size in the inline dimension. Turn the grid on its side using writing mode, the block and inline dimensions then change. So block size maps to height if we're in a horizontal writing mode and width if we're in a vertical writing mode. Then we have mappings for margin. Margin block start and margin block ends define the top and bottom margins when in a horizontal writing mode, and the left and right or right and left in a vertical writing mode. So as long as you keep in mind the concept of block and inline, these should make sense. I think probably these flow relative properties, they'll become the defaults. We'll tend to use those instead of physically bound properties and values. Now that actually raises issues of its own, because we have things like for value shorthands. You think about margin. Now margin, you can do top, right, bottom and left. Now we can't change that. In a logical world, it would make sense to specify both starts then both ends, which is what the grid area property does if you set all 4 lines at once. But we can't break the web. We can't tell everyone that at midnight on 31st December, your margin property is changing the order of values. We can't do that. So at some point, some future developers are going to look back and go, why is the margins set in that order? And why are they tied to the physical? And basically, that's why. So then initial values. Every CSS property has an initial value. That is the value if you haven't given it a value. Now it's useful to understand because those initial values control the default behaviour of things. If you set display flex on an element, for example, what happens? Well, the children start behaving like flex items. They display as a row, they go to their max content size but no larger, they don't wrap. This is because the minute our container becomes a flex container, all the other flex properties apply. they're ignored to that point, and then their initial values all kick in once their parent becomes a flex container. So the flex direction property is row, the justify content property is set to flex start. You can find what the initial values are in the spec, and you can also find them on the MDN property pages. So it's useful to remember this fact. Sometimes if you add one property and value in CSS, that will kind of cause other things to apply, particularly with layout. Now you might be happy with their initial values, or you might want to change them, but nothing mysterious is going on. This is all as defined. The properties always had those values. They just weren't doing anything, in this case until you created a flex container. So let's carry on thinking about layout. Now when we think about layout, it's really important that we start with what happens if we don't do any layout at all, because this is the state that CSS will always return to. We're always returning to normal flow, to block and inline layout. And we need to understand that this is the default state of layout. So this is the state we return to unless we do something else. Items participate in a block formatting context. We sometimes talk about this as kind of no layout, but it is layout. It's block and inline layout. Each box is a block thing or an inline thing. If you write some HTML and do nothing else, your HTML document defines a block formatting context, and the items inside participate in that. Block things do what block things do, inline things do what inline things do. And I think it's really important for us to see normal flow in that way. It is a layout method. And right out of the gate, CSS is doing work for us. We don't need to define what every single HTML element looks like. And we don't have to prevent things overlapping. CSS is doing that for us. You know, we're very fortunate we've got this amazing framework on which to base our designs. And so it's really important to work with it and not against it. If you start stripping everything away with a heavy-handed reset style sheet, you basically just give yourself the job of putting it all back again. And you're bound to forget things. So don't do that. You know, use the stuff that's already there and build on top of it. So once we understand that we've got layout and our items are participating in the block formatting context, we better understand what we're doing when we change the value of display. We're creating a different kind of layout. And when we do that, if we change things to flex or grid, we're changing formatting context. So I've got items here that are displaying one below the other as block items. So the children of the container are said to be participating in a block formatting context. If I change the value of display on their container to flex, the items now display alongside each other as flex items. They're no longer participating in the block formatting context, they're participating in a flex formatting context. And as we talked about before, that comes along with some initial values for the various flex properties. Or I might change the value to grid. The items now participate in a grid formatting context. Now by default that gives me a single column grid with implicit rows. I need to add some other grid properties in order to make something that looks like what we'd call a grid layout. For example, grid template columns with a track listing to get some tracks. Whether we grid or flex, we only change the value of display on that element. Only the direct children participate in the grid or flex formatting context. Their children go back to participating in a block formatting context. And you can see that in this example. And so it goes all the way down through the structure of your site. You either stay with a block formatting context or you switch to another formatting context. Inside that you return to a block formatting context and make the decision again. One box at a time all the way down. And once we're thinking like this, it becomes so much easier to switch contexts. We're not seeing grid and flexbox as two separate things. They're both a value of display. Use whichever works. Something which often seems to confuse people is generated content, and given we've just been talking about direct children of an element, it's a good place to mention it. I think that a lot of the issues around generated content are because of naming and history. So let's start with one bit of history. Pseudo elements use the double colon, pseudo classes use a single colon. This is the same for any pseudo elements, which act as if an HTML element was inserted into your document. In the past, they were defined with a single colon. Therefore, browsers maintain that syntax because we can't break the web. The other thing that confuses people is that before and after add the first and last child of the box you apply it to. So it's before the other children and after the other children. We can see this in grid. If I create a grid with one direct child, it will be auto-placed at top left. If I then add items of generated content before and after, These will be added as the first and last child of the element that is the grid container. And here they are. And they can be styled up just like any other grid item. I sometimes use this technique to do small features like adding lines either side of a heading. And so we get something like this. With the grid inspector on, you can see how the grid works. So don't be afraid to use grid for little touches like this. You know, often people feel that grid is only for like big layouts. You can also use it very usefully for small components as well. So sticking with normal flow, there are things that let us break the chain of normal flow one way or another. We have things that remove an element from flow. Now the obvious way to do that is to use position. We use position absolute and we've taken the item out of flow, we're now in charge. We need to control the position of our item. And then there are floats, which if you don't spend your life using CSS specs, you might not think are really out of flow because they do appear in the document where we expect them to appear. They don't overlap other elements, or do they? Now if you've ever added a background colour to content following a float, you'll see that actually they do. What happens when you float something is the line boxes of the stuff that comes after are shortened to make way for your floated thing. But otherwise the floated thing is taken out of flow. It overlaps the box of the thing that comes after. And so if we just stick around with the display specification, there's a value of flow root. Our page establishes our initial block formatting context. And a block formatting context, or BFC, has some features. Floats can't poke out the bottom, because obviously they can't poke out the bottom of your screen or out of the viewport. Margins don't collapse through it. And so this is quite useful because sometimes what you would like to do is create a BFC, block formatting context, in the middle of your layout. You could have a box that's got something floated in it, and if you made that box a block formatting context, then the float wouldn't poke out. That would be pretty useful. And so we can do this by saying display flow root. It creates a new block formatting context. Now, if you've ever used overflow to contain floats, this is what you're actually doing. If you use a value of overflow that could create scroll bars, you get a block formatting context, because if something is scrolling, you need to make sure it's all inside the thing. You can't have things poking out when scrolling is going on. So people would use overflow to cause floats to be contained. You occasionally got some other weird things went on when you did that. You might get shadows clipped and so on. So the nice thing about using flow root is that's all it does. It just creates the new BFC, and that's everything. It just contains floats and margins. So margins. We've just mentioned margins and saying that a block formatting context will contain margins. So let's think a bit about margins and margin collapsing, because that causes people all sorts of bother. The way margins behave has been defined since CSS 1, and it defined that vertical margins collapse. And this has been a source of frustration ever since. Now it makes sense when you think about the early web, when essentially all that was happening was documents were being formatted. If you've got a terrible sort of CMS that is outputting HTML and it outputs a whole bunch of empty paragraphs, you don't want a giant bit of space. You want all those margins and that content to collapse. And so that's what the margin collapsing was doing. It was meaning that, you know, you didn't get big chunks of space between headings and paragraphs and so on. What happens when a margin collapses? The space between the two elements becomes the larger of the two margins. So the smaller margin it actually sort of ends up inside the larger one. So the first rule of margin collapsing is that they only collapse in the block direction, so between paragraphs. And it's only things participating in the block formatting context that have margins that collapse. So flex and grid items do not collapse margins. If you have two elements displaying one after the other in normal flow, the bottom margin of the first element will collapse with the top margin of the following element. So that's stopping getting a big gap between your headings and paragraphs, basically. So in this example, the 20 pixel top margin is combining with the 50 pixel bottom margin of the item below. So we end up with 50 pixels, not 70, which there would be if they were added together. The sort of empty paragraph situation, if you've got completely empty boxes, the top and bottom margin combines. And it may then collapse with other margins, which is what's happening here. The empty box is between two visible ones. If you give it a border, it keeps its margins, although they're going to still collapse with the ones above and below. As I say, empty boxes collapsing, that makes sense. It stops you getting big gaps in your document. Now this is the one that really catches people out. It doesn't seem very intuitive. You can end up with the margin on a child item combining with the margin on the parent, so essentially ending up outside of the box. So I've got items here, they're inside a box with a light blue background. The items have margins on them, but no blue background is showing above the first and below the last. That's because it's collapsing with the other margins, and so it's ending up outside the box. If you add a border to the box, it stops the collapsing, and you can see here the light blue is showing of the background it's showing through. I'm highlighting this here in DevTools. DevTools of any browser are really useful to identify where the margins are ending up. So if you seem to be losing a gap that you expected, inspect the item with DevTools, see where it places the margin. If it's come out of the box, you need to add something, a border, a pixel of padding, or something that will stop that happening. It will keep it trapped, or make the container a BFC. So let's move on to alignment. Alignment deals with how things are aligned within their layout method, and also with space distribution. How do we distribute extra space left over once we've laid out items in a grid or a flex layout? And the reason I talk about writing modes first when I teach CSS is because alignment is a lot easier to understand once you understand things like the block and inline dimensions and start and end. So alignment is defined for all layout methods, for flex and grid, for block and inline layout. This means that we get consistent alignment no matter which value of display we want to use. So when we talk about alignment, we need to talk about two things. We need to talk about the distribution of space between items in a particular formatting context, and we need to talk about the alignment of items within their own area in that layout. And these are the two things that affect alignment of content. So the first, the distribution of space, is the most easily understood in grid layout. I generally teach alignment first in grid, then explain how the other layouts differ, because in grid you've always got two axes. So I've got a grid here with fixed size tracks. They're not large enough to fill the grid area, so I've got extra space in my grid container in both dimensions, block and inline. By default, the tracks are aligned to start in both dimensions, so they're sort of up there top left because I'm working in English. If I want to space things out in the inline dimension, I use justify content. Think about justify as when we justify words in a sentence. It works in the inline dimension. If I want to space things out in the block dimension, I use align content. So here in the inline dimension, I've taken the spare space and placed it between the tracks, making the gap bigger. At Firefox DevTools, it shows you can see what's happening there. And we can do the same thing in the block dimension. So my spare space is now put before the tracks and they're all moved to the end. Now, if you're in Flexbox, the thing with Flexbox is you can change the main axis. You can be a row or a column. So rather than thinking about block and inline, we need to think about the main and cross axis. So the justify content property works on the main axis. So unless you've changed flex direction, that's going to be row and therefore inline to start with. The align content property works on the cross axis, and only if you've got wrapped flex lines and extra space in that dimension. So we'll look at justify content. And in this case, the spare space has been moved to the beginning because we've said justify content flex end. And we can also use align content. As I say, you need to have multiple flex lines and you need to have some spare space, but it works in exactly the same way. So here I've done space around, so the spare space is above and below each line. Now for the content property to do anything, you have to have extra space in the alignment dimension. If you've got flex or grid items or grid tracks packed in, taking up all the space, then these properties will do nothing. So you have to have spare space for the content properties to work because they distribute spare space. That's what they do. They don't do anything else. And then we have alignment of items inside an area. Again, this is easier to understand in grid. So I've got some grid items here. They're displayed within their grid area. They are all stretched over grid cells. And the properties we want to use to move the item around inside the area are justify self and align self. The initial value for these properties is stretch, and that's why boxes stretch to full height and width, unless the item has an aspect ratio, such as an image, in which case it will be aligned to start. To align on the inline axis, we again use the property which starts with justify. So justify self end on the first item, aligns it to the end in the inline dimension. To align on the block axis, we use the property which begins align self, and align the item to the end on the block dimension. And so that item, item 1, you can see it's now down bottom right because that's both ends. And you can set all the items at once with the properties justify items and align items. That basically just sets all of their self properties together. So if you switch into Flexbox, we don't have a concept of justify self on the main axis. Now the reason for that is there's no area as in grid. When you have flex items on the main axis, they all work as a group. So you can sort of spread them out as a group, or you can move them to one end or the other, but you can't deal with individual items. So that's really important. We've got all of these alignment properties, and they are specified for all layout methods, but some of them aren't going to apply for all of the layout methods, and they won't make sense in that particular layout method. And so this is the case with Flexbox. We can use align self on the cross axis, and what this does is it moves the item inside the flex line. Once again, align items will change all of the items. So as a recap, properties beginning with justify do main axis alignment in Flexbox and inline axis alignment in grid. Flexbox only supports main axis alignment because it treats all the items like a group. Properties that begin with align do cross-axis alignment in Flexbox and block axis alignment in grid. Properties that end in content do space distribution outside of tracks of items, no spare space, and they don't do anything at all. Properties ending in items or self align the item inside a grid area, and in Flex, align items and align self allow the alignment of a single item against others on the cross-axis. And so that's alignment. I think alignment is one of those places where you do just need to remember how it works and which names apply to what, because you just have to remember. And if you get yourself into DevTools and have a look, you can kind of see what's going on. So let's move on from alignment and have a look at sizing. So we've got this specification called box sizing. It was formerly known as the CSS intrinsic and extrinsic sizing specification, and it defines how big things are in our layouts. And you might have noticed at no point so far have I explained the box model. I think that most sort of CSS talks and books I've written, and I must have explained the box model hundreds of times in different ways throughout my career. I still think it's important. You need to understand what the box model is and how it works. I just think it's far less important than it was. And as I say, I've talked about the box model probably more than most. And the reason it was really important before was to do with sizing, because the only way we could make something that looked like a grid was essentially to use floats. And even, to be honest, with Flexbox, if you make a grid out of Flexbox, you have to give the items a size in percentages. And you have to make sure that all of the things in the layout have a consistent size, including their margins, padding and borders. And all that had to add up to 100%, and you would get something that looked like a grid as long as you did that really carefully on every row. So add to the fact that that was the only way we could make something that looked like a grid, and remember that within very recent memory, the width we gave our items wasn't even the width they took up. We had to take padding and borders into account. And so it's here that we need to start talking about the box model. And so this is how I talk about the box model today, a sort of a reduced version with added dev tools. So everything in CSS is a box. But when we talk about the box model, we're talking about the block level box, and it's a very specific thing. And it has some default behavior. It expands to fill the inline direction, and it grows in the block direction only to the size of the content. Now we know that, if you put a paragraph on the page with a background, such as maybe like this box here, or a div, it will fill the inline direction. It'll get as wide as the page or as wide as its container, but it will only get as tall as the content inside. It doesn't stretch down to the bottom of the viewport. So we can give our box a width and or a height. Now, when we do this, CSS has decided what that size means. and sort of take into account the various things that make up a box, which we can see if we look at DevTools. So a box has content, and we talk about that we refer to that as the content box. That's where the content is, and it will be wrapping the content and then going to the size that you've given it, or expanding out to as much space that it's got. So we refer to that as the content box. Now you might give it some padding. Now padding is added round the edge of the content, and the edge of that is referred to as the padding box. Now our box might have a visible border. Now if you add a visible border, then that's going to be added to the outside of the padding. That's the border box. And the box might have a margin. Now margins are invisible, but they're added to the outside of the border, and they push things away that are outside the box. And that defines the margin box. So you give your box a width and a height, or an inline size and block size if we're using logical properties. Now what is that size? Now by default, the size that you give it is the content box. So that means that if you give your box a width, the visible space it takes up is that width plus the padding plus the border, which is why everyone was really annoyed about how the box model worked, because you could give, if you wanted to have 4 things next to each other on the page and you gave them a width of 25%, but then you gave them some padding, then one of them comes off the end and ends up on the next row because they're all floated. But these days, if you want to use another box, you can use the specific keyword for that box. Now, pretty much the entire web has agreed, because of that problem of things popping off the end when you've given them all 25%, that border box is the best way to size boxes. And what that means is that the width you define is the width of the visible box on the page, and your padding and your border are sort of taken off that. So you're actually setting the visible size by using border box. And so to do that, you say box sizing, border box, and all of your calculations are then taken from the size of the border. So it's the visible box that you're seeing. That's what is being defined. And so we go back to sizing. And as I say, when we were doing the floating thing, or even making grids with Flexbox, sizing is pretty straightforward. So everything is either a length or it was a percentage, and percentages resolve to a length. So we, as web developers, could set those sizes, work out the column widths to make sure they didn't end up more than 100%, and all was well. But the thing is now, so our layout methods kind of do their own sizing. You can have flex items and they'll work out how much space to take up, and you can do the same in grid. And this is all being worked out by the layout method working out what is the minimum size of the content and what is the maximum size of the content. And so we need to understand how small things can be and how big they can be to have any idea what is going on in layout. So if I take a 2-column grid, 2 grid items, the 2 items, have got the same text. We've got sort of 4 items on 2 rows, and they've got sort of similar text in there, but one of the items has got extra text in. Now the first column there is set to min content and the second to max content, and so you can see the difference between the minimum and the maximum size of our text. So on the first column, that's gone to min content size. So what happens is all of the content, any soft wrapping, so our items have wrapped onto 2 lines, it'll get as small as possible. If there's something with a width in it, that would have held it out, but there isn't, so it gets as small as it can with no overlaps. On the second column, you've gone to max content size, and so you can see that the longer string is unwrapped. If you had a massive long sentence in there, it would probably cause overflow, because it would keep on growing. That's its max content size. And so that's how any content-based sizing is worked out. The browser looks at the minimum size and the maximum size, and it works out how much space to give things. You can see this really nicely in Flexbox. If I've got 3 items here, now they're slightly different sizes, and I'm using the flex initial values. They don't grow to fill the space. So what they do is they go to max content if they can. So they'll get as big as they can, and then they'll stop growing. Now if I give them flex auto, that's like setting flex 1 auto, so things can grow and shrink from auto. Now they kind of look like we've got 3 equally sized items there, but that's only because they've got around the same amount of content. They won't be exactly the same if you inspected them in DevTools. If we add more content to one of our items, you can see that that item that's got a lot of content has been given more space. The smaller items aren't getting any smaller than min content, but they are shrinking down to make space for that bigger item. So if you do want 3 equal items in Flexbox, no matter what content you have, you need to set your flex spaces to 0. And what you're doing there, and you do that if you use the shorthand flex 1, is you're saying to the browser, these items don't have any intrinsic size. Ignore what's in them, set them all to 0, and then distribute the space between them. So kind of understanding that that's what the browser is doing. If you're using auto sizing in Flexbox or Grid, then the browser is going to figure out how best to display those items and not squish something big into a tiny box, or let something, have loads of space around the smaller items, which is kind of the equal layout that we see here. If you want it, you can absolutely have it, but by default, especially when you think of Flexbox, what it's really good at is taking a bunch of unevenly sized items and just displaying them the best way possible, which was very, very hard to do in the past. We had to work that out and assign more size to different things. So, you can turn that off, but that's how it's working it out. It's looking at how big the stuff is, and then it's sharing out the space. Just sort of interestingly, there's a slight difference in Grid. So this is a Grid layout with 3 tracks set to auto. It looks a bit different to that Flex layout. The smaller items haven't gone to min content. And this is due to the difference in the way that Grid and Flex work out their auto sizing. So what happens with Flexbox is it will start at max content and it removes space. So essentially you can imagine that you have your items, the browser spreads them all out, it says, well, I've got too much stuff to fit into this space, and so I'm going to need to remove some space. And then it starts to remove space accordingly, removing less space from the big thing or the big things. What happens with Grid is it takes everything to min content size and then goes, oh right, we've got more space. And so then it starts to add space to the things, with the bigger thing getting more of that space. Now all browsers do exactly the same thing for each layout method, and that's because these things are detailed in the specifications. And really that's why we have far fewer differences in browser rendering these days, is that modern specifications are far, far more detailed than they were in the past. So in the past, where a lot of stuff might have just been kind of left up to the browser to figure out what they were going to do, these days every little detail is carefully written down, and also tests are created to make sure that every browser does the same thing, because that is what we want as web developers. As web developers, we want browsers to do exactly the same thing when we throw some code at it, and increasingly that is what's happening. It's very, very different these days to what it was in the past, the sort of early days of CSS. And so I've just mentioned specifications, and so I think that's the final bit of advice I want to leave you with, is just not to be afraid of specs. Modern CSS specs are very detailed, but they're a lot more readable than I think a lot of people believe, and they do contain examples. And with a little bit of work you can learn to read them, and then anytime you are puzzled as to why CSS is doing something, you can take a look and find out. I wrote an article a little while ago, but it's still all perfectly sort of up to date really in terms of the content, just taking you through, if you want to research a property in a spec, what are the steps that you do to research that property and figure out how it works in the spec. So that's something you can have a look through. You really can sort of feel like you've got some superpowers when someone on your team comes and says, oh, what on earth's going on here? And you're like, oh, I don't know what's going on. Let's find out. And you can look in the spec and find out. The MDN pages are kind of like the notes on the spec. I've done a lot of writing for MDN over the years, and when I'm doing that, what I'm trying to do is just add that little bit more detail, but still guide people back into spec language and how things are described in the spec. Because I feel that empowers people to find out more stuff. But the MDM pages are also, for each property, they're a really good place to look, because all of the different values will be detailed and how they might be used. So certainly don't be afraid to dive into the specifications and look up stuff, and try and see, as you sort of become more familiar with that, it will actually save you an awful lot of time, because you can be like, well, I'm not sure if that's the browser or what. Hey, let's look in the spec and find out. So I hope this has been useful. That's all I've got time for today. I will share some resources that you can, I write a lot of articles that are basically just unpacking stuff like this. So you can take a look at those and learn a bit more. And I, really hope this has been useful. Keep learning and enjoy the rest of the conference. Thank you.
Wow, thank you very much. That was really interesting and I learned a lot. I think I have to rewatch the whole presentation once again because that was really a lot of content and I was really fascinated about what has happened in CSS the first time I touched it, and I was not aware of this logical and physical how was it called? Logical and physical layout thing?
Properties. Yeah.
Properties.
Yeah. Logical properties, flow relative properties. Yeah.
They were quite interesting. We also do have some questions from the chat. So the first one is, why would I still use floats in CSS when I can use either flex or grid layout?
Well, if you want to use it for what it was designed for, which is floating an item left or right, which is something that you might want to do still. If you've got an image or something, you want the text wrap around it. Also, if you want to use CSS shapes, at the moment, you can only use a CSS shape to, curve text around a circle or something. You can only use that on floated elements at the moment. So you might float something in order to be able to use shapes and let text wrap around an interesting shape.
Okay. And the second question from Thomas Hertog, if he understood it correctly, that using flex or grid items are still contained in an own block formatting context?
So the outer box, if you say display flex or display grid, the outer box is a block. It's not a block formatting context because that would mean that you had block and inline layout inside. You've got a flex or a grid formatting context, but you do have a block level box. So it behaves amongst all of the other boxes on the page like a block box. So if you say display grid on something, it'll behave like other block things. It'll expand to the full inline direction and so on. So it'll behave like a block item. But inside, what you've got is a grid formatting context, which is why you get grid items.
Okay, thank you. I also have a question from my side. So back in the days when I wrote CSS heavily, we all had these shortages for WebKit and Mozilla and things like that because of the missing adaptations from browsers. How fast are they adapting nowadays? So everything we heard in the talk is, I assume, now generally rolled out. But how far big, what is, for example, for this logical, I forgot the word all the time, for the logical properties.
Yeah.
What is the so I'm pretty sure I cannot use Internet Explorer 4 for that, but the last 2-3 years browser versions are using that already. Is there a page or something where I can check what I can actually use, what is in the specification and what not?
Yeah, I mean, the MDN, I mean, you can use Can I Use will give you a kind of broad brushstrokes overview of what's, but that tends to be like an entire spec. The MDN property pages will tell you exactly what supports which property and which values of properties. So if you want very detailed browser information, MDN is probably the place to go, and the actual property page on MDN. And what I would say about browsers is these days we don't tend to have so much of a problem of browsers with bugs in implementations. So if a browser implements something, it's generally to spec. I mean, obviously, browsers are software and software has bugs, and sometimes things will have bugs, but you haven't got wildly different implementations of things, and things are much, the whole web platform is much better tested these days to make sure that when some new CSS lands in a spec, it can actually work in different browsers. So you tend not to have buggy problems. What you still are going to have, because browsers have different sort of business ideas as to which things to start implementing. You're going to have a browser that has not yet implemented something. I mean, that's always going to happen because they don't all do it at the same time. But that's actually a lot easier to cope with. And we've got things like feature queries where you can say, at supports display grid to check that browser supports display grid and then fork your code accordingly. So we've got better ways of coping with that. It's generally easier to cope with lack of support because you can, create some kind of fallback and then build on that than it is to cope with a browser which says it supports it but does something weird. That's actually quite difficult to deal with.
Okay, we are talking about browser, and you said that a lot of things are more now clearly specified in the specification. Is there still the need to write those reset files for some styles or something? Is there currently also something weirdly odd in some browser which you are aware of, which you have to reset because it's totally not behaving like the specification?
Not really. I think the sort of whole idea of reset style sheets, they were really useful when browsers did quite different things by default. That isn't so much the case now. I mean, it might be there's a few bits and bobs that, particularly things like around form elements are probably the biggest thing at this point that behave differently across browsers because they're a little bit weird. They're sort of their own sort of thing, and they behave differently depending on the operating system and the browser. So, you might have a few things, but I would generally say don't just wipe everything away with a big reset style sheet these days, because you just make it life hard for yourself. You've got to put it all back. And a lot of it's going to actually be fine. So you probably don't need a very heavy-handed, but I think most people who work with CSS all day probably have a little set of things. They're like, I'm going to, I always start my project with these things. So that rather than just, removing everything off everything.
Okay. What is your most favorite feature actually of CSS? So when you can take a look at the whole specification, what is the thing you find is the more likely the most impressive kind of thing, or what you would love to highlight actually?
Actually, I mean, because obviously, I'm sort of fairly well known for talking about layout and grid in particular. But actually, I think a lot of the things that I find most sort of interesting are those things that just fix problems that we've had for years, and then something comes into CSS that fixes that little thing. A bit like display flow root clearing floats, which having like clear fix hacks and all. I mean, we just had these problems for years. I like those little things because I think it's very rewarding, to sort of see those small things get picked off and fixed, and then it's not a pain point for a developer in the future. And I really like that stuff. I mean, the big specs are great fun to work on and to see people get excited about them. But there's just something nice about thinking, yeah, that long-standing issue in the web platform, the thing that we've been battling with for like 10 years or something, is now just gone. And I like that. That's kind of fun.
Okay. I can imagine that is quite satisfying also, I assume. So I heard a lot of new things now regarding CSS, and also a lot of other people heard most likely new things. So the feedback is quite positive. So when I have now a junior developer who needs to do a CSS task, where would you pinpoint him to learn about CSS in the best way? Because I think the specification will be a little bit overwhelming at the beginning. So what is the resource you would recommend for a junior to start with CSS?
So over at Google, I edited a learning resource on the web.dev site, which is Learn CSS, and that is that most of that was written by Andy Bell, who is a great sort of CSS writer, and it's basically a sort of a course running through all the basics of CSS. So that's a really good place to go if you were totally just getting started. It's little short lessons taking you through CSS, so that's a good place to look. And then I think, having done something like that, a sort of just a kind of a beginner's guide, MDN is a great place to go and just to look at the different properties that you can use. There's loads of guides on MDN of how to use different things, what they're to be used for. So those are sort of two good free resources that anyone can go and look at. And I would say that, as I said in the talk, even if you've been doing CSS for ages, it's kind of worth revisiting this stuff, revisiting modern materials, because things have changed quite a lot.
Okay. Would you also recommend, if you have currently a code base or something and you came across this width and height properties, to start replacing them with the new logical properties? Or what is your recommendation for migration actually?
I don't think you have to replace these things. I think it's the sort of thing where because you might not necessarily use different writing modes because you're typesetting, a language that's written in a different writing mode. You might be doing that particularly with the sort of the vertical writing modes, you're more likely to be doing that because you're doing something creative. You want to run a heading down a page. In that case, you probably want to use the logical properties because it's just easier. And, you might think about retrofitting if, for example, you have content which is going to be translated into Arabic. That is a really good place to start looking at using sort of, start and end and things, because the minute that content is written right to left, a lot of things are going to change. You're going to have padding in the wrong place in between a label and the form field, for example. So it really depends on what you're doing. If you are looking at content that needs to be translated, then they're really, really useful to start looking at, and they have good browser support, because then I think probably the left to right, right to left thing is the thing that most people are going to come across. And say setting things like your padding between stuff and things, rather than using left and so on, that using you sort of start and end, that's actually going to make your life easier.
Okay. But you also assume that we will see width and height quite for a long time, or is there some kind of grace period? I know you do not want to break the web, but is there, for example, we deprecated this now and in 15 years because most likely no browser or something like that. I don't know, we need to use websites. Okay, that will be a little bit hard. Should support that anymore? Is there some kind of grace period, or you leave everything in there?
They're not going to go away. And the fact is that sometimes you will want width because you will actually want to talk about the physical width of something. That is actually something that you may want to do because the actual width of the screen is a thing, even if you're using a vertical writing mode. So I think that possibly in the future, people will default to the logical flow relative properties and values, but the other things aren't going to go away. I mean, partly because of the breaking the web thing, but also just because they are still useful, because you do sometimes want to relate something to the physical dimensions of the screen rather than the flow of the content.
Okay. Also, for me, quite interesting. There are also no plans to somehow deprecate some kind of layout or things like as a layout systems, because we have now flex grid and the box layout, and they will stay the same because they're really tightly specified with a big group. So they are also staying in there, I assume. Which brings me back to the next question. I just put this as a statement here. How is the specification process working? Are there a lot of companies involved, many people involved, or how does the specification process look like for CSS?
So, I mean, the CSS working group is the group that sort of works on CSS. And so anything that you want to get into CSS has to go through the CSS working group. That is a bunch of people. A lot of people are browser engineers. So they actually work on browsers. So from the big companies, from Google and Firefox and Microsoft and so on, and Apple. There's also people who work in print, because a lot of people use CSS for printing books and so on. So there's people like that. There's also various people who are invited experts, which I am at the moment, although I'll soon be there on behalf of Google, who are just brought in because they have knowledge in terms of CSS and expertise. And a lot of those people are actually more from a development background than being browser engineers. So yeah, I mean, anything gets discussed. So whether it is someone raising an issue on our GitHub repository saying, I think it would be cool to have something like this in CSS, or whether it's a browser wanting to add a new feature, all of those things are going to come to the group and we talk about them. And feedback will be given from other browsers. Like one browser might say, hey, I want to implement this shiny new thing. And another browser is going to say, hang on, I don't think that that's possible to work in other engines because we're different. And so that all has to be discussed to make sure, because you can't push a feature through into CSS that is only going to work in one browser. It has to be able to work in more than one browser. So a lot of the discussions are around that, how is that all going to work to make sure that the web stays interoperable.